down there? Oh, good. Let's turn on the other one. Okay. So really BRICS as an outgrowth of you see on the left-hand side there, NDAR, which was the National Database of Autism Research. That was Greg Farber, who was here earlier, talked a little bit about. So we took some of those ideas. This is actually the transformation into this particular version of PowerPoint. This is the BRICS platform. So these are the kinds of things that influence the BRICS platform, and these are some of the projects that we're supporting with the BRICS platform. I developed MIPAV at NIH, which is the Medical Image Process Analysis Visualization. We use that tool to actually package up the image data to submit into the BRICS platform. So that's DICOM, NIFTY, Analyze, MIPAV format, and pretty much any format that imaging format that's out there. We also use the NINDS or NIPHD clinical trials database, which is essentially an electronic data capture tool. Like a REDCap, we integrated that into our platform. We call it ProForms now, so we can do electronic data capture. Big data to knowledge. This is where we started about 2 years ago, or not 2 years ago, about a year ago. We said some of the tools that we put together to build BRICS, that are BRICS, they each had, or 3 of them had, a different definition of what a study is, and they weren't always consistent. So we started to build a unified study, and we went out there and looked for a spec, and that's where we found DAT. And I actually had loosely been working with Working Group 3 anyhow. So we said, well, if we make our unified study consistent with DAT, we can then make all the data that's collected, data sets that are collected with the BRICS platform, we can make it discoverable through the DataMed tool. We've been involved with the NLM BMIC Working Group Committee and working with Lisa for a long time, and as well as the other NLM people through the CDE Task Force Working Group. And then the NINDS Common Data Elements, which is kind of also involved in the whole BMIC environment. And I think they're also rendered up at by the NLM CDE browser. Okay, so then we have the BRICS platform, and then we support FITBUR. We can actually deploy it. So there are 2 parts of a BRICS system. There's the public-facing side, which is just a Drupal interface, and then there's the portal or the login side. The portal side all look pretty much the same. They have a different window dressing, but the public side can be individual, uniquely enhanced to specifically meet the needs of each particular project. So here's one example of a project they were working with, the Common Data Repository for Numeracy and Science, but you could easily replace that with IE. We went to the NLM CDE site, and we tried to find the data elements. We searched for the data elements that were needed to collect the information they needed for this particular project. We didn't really want to reinvent them. We really wanted to use kind of the common data elements. And then we put those into our data dictionary. Our data dictionary is different from the NLM data dictionary. I think the NLM CDE browser or the NINDS CDE browser are reference data dictionaries. Ours is a active data dictionary because we actually collect data against it. So we can't go in and change the data elements in any way because that will affect our database, where you could go in there and update data elements with reversible values and not directly affect the database. So the data can be, we build electronic forms, we call them e-forms, to collect that data that's based on those common data elements. So our flow is the researchers define the forms that they want to collect. You then define a form structure for that form, and that form structure is a list of data elements, groups of data elements in that form. But then that form can be rendered in ProForms as an electronic form where data can actually be input by the user. And you can have all the kinds of logics, range checking and auto calculation of questions or data elements. Then that data goes in the long-term repository, and then we make that data available through the query that's part of the system. Okay, so I'm trying to go through this really quickly because I'm we're way over time anyhow. So these are the BRICS that make up the BRICS system. The data repository, data dictionary, which is actually one of the key components, the GUID, which is the global unique ID system, because all our data that goes into the system is de-identified data, but we had to come up with a consistent way of collecting or assigning a random number to a particular individual so we could track that data or associate that data over time and over location. And that was actually developed as part of the NDAR, and we've continued to adapt it and use it in the BRICS system. McAuliffe I talked about for imaging, Proforms, electronic data capture tool, like REDCap, like CDE. Then you can query. And the other interesting thing, I think, is what we call a meta study. So the idea here is that you can query studies A, B, and C for the BSI 18 form, and then you can say, I want all subjects who are male between 30 and 35 who have a score of whatever is reasonable, 10. And you can get that cohort. That's a snapshot of the data at this time. You can then take that data, snapshot, put it into the meta-study. Think of the meta-study as a shoebox. You put that snapshot of the data. You can put the query into the data or into the meta-study. You can also download that data, generate some derived data, do statistical analysis. You can put that up into the meta-study, write your paper, and then you publish that meta-study. Published meta-study gets a DOI that then you can put in your paper so that if people read your paper, they go, oh, here's the DOI. I will go to FitBur, go to that meta-study, get the data. I can look at what they actually did for their query and any other associated. You can upload software, et cetera, et cetera. The neat part about it is now that the meta-study definition is going to be consistent with DATS, we can easily take that the metadata about the meta-study and import it into DATS or into DATS format and get it into the DataMed, and now it will be discoverable also in DataMed fairly easily. And so that was the long-term goal. This is just another kind of, I won't go through this too much other than this is kind of a bigger picture of system architecture. You got Proforms and it connects to the data dictionary and you submit your data. If you're using REDCap, you can export the data elements REDCap format. You have to validate the data against the data dictionary. It means that it's checking that if you're submitting age and years and you try to submit -5, it's going to not let you submit that data into the repository. So we do some QA, QC before the data actually gets into the system. Gets into the system, you query, and then you can download that data. And then put it into a meta-study for future use or reference, future reference, and other people's use. The one other unique thing about the meta-study is it's not queryable. The data, while it's in the repository, is queryable. Here it's more used for reference, and it's really a snapshot of that query at the time that you got that and you wrote your paper and did your analysis. Where if somebody else came in later, they could actually grab your query if you saved it in the meta-study, rerun the query 6 months later, and there might be more data related to that particular area of interest later. And that's really it. I could give a demo, but I think I'd be going too long on that.